Consider you are inside a radar control tower. You will find a panel like this, some circles and two lines, intersecting lines. So immediately you find that there is a dot, and it confirms that there is some object in your radar system. I mean, in the range of your radar system. And so, what is your duty now is to inform your superior. So, what you will inform? You will inform that some unidentifying object is in your range, but this is not sufficient for this information. So you have to tell where, where, how, what is the distance of the object from you. You are here. So what you will do to understand this panel, you need to know polar coordinate system. Polar coordinate system. Polar coordinate system. So what will do now? You have to draw a line like this. And what is this line says? This is the distance. Distance. We denote it by r, some distance from you, and this is the origin or your position. And one more thing you have to tell that what is the angle? Theta. Okay, I'm not writing it theta, it is phi. Okay, there is a reason you can write it from theta, but I'm writing it phi for some purpose, obviously. So what you have to inform, what is r and theta, sorry, phi. These are the polar coordinates. So this point can be referred as r phi. So if the point is here, now the distance will be like this, and the angle will be from here to this. So you can see that it is 180 degree plus, isn't it? More than 180 from here. Okay, someone can say that our point may be somewhere else. Let it be here. So what will be the distance? The distance will be something this like this, and the angle, the angle you measured from this straight line to this straight line. The whole thing is the angle. So this angle can vary from here to anti-clockwise, and it comes to here. So phi varies from 0 to 2 pi. Is that it? Phi varies from 0 to 2 pi. But what about r? R is distance. The smallest distance you can achieve is 0. So r cannot be less than 0. So r greater or equal to 0 to any extent, theoretically any extent. If you are not talking about a radar, a practical radar. So this is the thought of the polar coordinate system by which you can identify an object or a point by an angle phi, and another coordinate distance r by position vector. Position vector. So this r is position vector. Actually, position is not vector now yet, but okay, it is position vector for simplicity. And the distance from origin, So you have to remind it that the angle should be measured from this point. Okay, you can say, oh, why not this point? It's okay. You can think about this point or this point. But the main idea is this line. This line is the main idea. You have to take from this line to this way and come to the point, or come to the radius, position, distance from origin, what you say, this line. In vector analysis, we call it the position vector. We call this position vector, but we are not calling it now position vector. Okay. So here we will discuss the relation between Cartesian and polar coordinate. So what we have to do? We need a point. Let it be here, here. So we'll draw some line from origin to this point, a line. Now, what we can say, we have to understand that these lines can form an Cartesian coordinate. We name it x and y. But from origin to this point P, let it be P, the distance is r according to polar coordinate, and angle is theta. So what we'll do? We'll drop two perpendiculars from this point to the axis, to this axis, and we'll name it. Okay, this is not the perpendicular, this is something, let me, this perpendicular. So OA and B. Nice and good. Now we will use a basic geometry. This is a triangle with this angle is pi by 2, and as well as this angle is also pi by 2. Maybe you can see that this is not in figure. It is something not pi by 2, but assume that. So what will we get now? Look, from this triangle OAB, we have some data also. OP equals to R, and OA equals to, actually this is X, and this OB is Y. In the same manner, PB is X and PA is Y. So OA equals to X and AP equals to Y. Now see that AP by OP equals to sin theta. From trigonometry, you can see that this AP by this OR gives us sin theta. So AP is Y and OP is R, and it is sin theta again. So Y equals to R sin theta. In the same manner, if you write OA by OP, it gives you cos theta, and so X equals to R cos theta. So we got two relations, but these are not sufficient yet. We can do something further. So x square plus y square, what will, you can calculate it? You can calculate it easily. It gives us r square and sin square theta plus cos square theta. Actually, I'm writing it without proper order. We have to write it with proper order. So it is r square, and for x it is cos that means cos square theta plus sin square theta. But this is nothing but 1, isn't it? You know it. So x square plus y square equals to r square, or r equals to x square plus y square and their root. And next we can divide this. Y by x equals to r sin theta by r cos theta, or tan theta equals to y by x. So you can calculate theta by tan inverse y by x. So we got two relations, theta and where is our r. So what is the use of this? When you are given these data r and theta, you can convert it. You can convert polar system to the Cartesian, and if you have the x and y values, then from Cartesian you can go to polar coordinate by this relation. So these two relation refers as Cartesian to polar, whereas this relation gives us polar to Cartesian. Cartesian. That's the transformation. You have to remind it, you have to remember it for your next journey to the physics